This is the video for Unit 4, Lesson 3 on horizontal asymptotes. So the goal is going to be to determine a horizontal asymptote of a rational function. We've already seen how to find a vertical asymptote, how to find the x and y intercepts, and now the missing piece we kind of need to eventually draw our own graphs is going to be a horizontal asymptote. A horizontal asymptote is a horizontal line, and it really guides the end behavior of a graph. So we saw end behavior a lot when we talked about polynomials. And so we're using a horizontal asymptote to describe that end behavior now. So instead of going to positive or negative infinity like it did for polynomials, some of these are now going to start to approach a value when you go all the way to the left or all the way to the right. So we're going to have a couple different cases here that we're going to see. So the first case we're going to see, and this is the one we probably have seen come up quite a bit already, is when we talk about a horizontal asymptote and it's approaching 0. So what we're going to find is when the degree of the numerator is less than the degree of the denominator, when we look at that end behavior, I should say positive infinity, if I was to look at the left tail as it goes to negative infinity, it's actually not going up or down. It's actually getting really close to that 0, y equals 0 line. So as x gets very, very large, the output is getting very, very small, and it's going to be going to 0. Same idea when I go to the right-hand side. If I look at that right tail, as I go all the way to the right, instead of it going up or down, it's actually getting really close to y equals 0. So our horizontal asymptote would simply just be y equals 0. So that's where our end behavior approaches. And that's whenever our degree on the bottom is larger than the degree on the top. The second case we have is what happens when our, and that should be a positive infinity, what happens when the degree on top is the same. So again, you can see this is an example where we have x is a 1 degree, this is a 1 degree. So what happens when the degree on top and bottom are exactly the same? So it is still going to have a horizontal asymptote. What we're going to find though is it's actually going to be just a ratio of those leading coefficients. So we're going to find that we have a 6x over 3x. So if I was to go ahead and simplify, it actually simplifies to be roughly a 2, right? Because I'm going to ignore the 7 and the 1. And so you can see when I look at my left tail, it actually does approach 2. Gets really close to this 2 line. And same thing when I go to the right. So notice it's not going up or down. There's no going up. There's no going down, right? It's getting horizontal and getting really close to that 2. And so our horizontal asymptote would be y equals 2. But again, if you just take a ratio of the coefficients, that would be your answer. And then finally, the last case is what happens when the degree on top is larger than the degree on the bottom. So this example, I have a degree 3, I have a degree 1. So that means the top is going to get very, very large. The bottom isn't going to get large as fast. So even if I wrote it as a ratio for you to see, you see how this would simplify to be like an x squared, right? So nothing's going to restrict it. So you could see in this example, and that should be positive, this one actually is going down. This one's going up. So there's no horizontal asymptote. Right? So notice it's not getting closer to a value. This is the ones that we kind of saw in the last unit. It's not tapering off at all. So we would say there's no horizontal asymptote. And that's if the degree on top's bigger than the degree on the bottom. So for the examples we're going to see here, all we're really doing is finding the domain, the vertical asymptotes, and the horizontal asymptote. So the first thing we always want to do if we're able to factor, we want to factor. So on the top, nothing factors with 5x. On the bottom, I could actually factor that out. So I have 5x on top. That's a trinomial with an a value of 1. So I have minus 3 and minus 1. And again, if you need to review factoring, you can watch one of the previous videos, but I'm just going to jump to that piece. And so it's then asking for the domain. So the domain is if I set the reminder, if I set the bottom equal to 0, what do I get? So x cannot equal 3 and x cannot equal 1. The next thing we're looking for is the vertical asymptote. So remember, that's just kind of like doing the opposite of what I just wrote. So I'm saying at 3 and 1 are asymptotes. And then the horizontal, that's the one that's new, right? So I don't have to necessarily use like this, just the 5x. I'm really just looking at on the top, I have a 5x. On the bottom, the biggest degree is x squared. So I have 5x over x squared essentially, which is kind of like a 5 over x. And so the degree on top is bigger than or smaller than the degree on the bottom. So you can see the bottom is going to get larger faster. So right away, my horizontal asymptote we know is going to be y equals 0 because the degree on bottom is bigger. And then I can always throw in a graphing calculator to double check, but you can see it's going to get really, really close to 0 if I go all the way to the left and all the way to the right. For the next example, same thing. I'm going to go ahead and try to factor it out. So on the top, nothing factors. On the bottom, it actually does factor. So x plus 3, x plus 2. Same thing. So I'm going to do my domain is what am I not allowed to have? I'm not allowed to have, and that's whatever's in the bottom. Negative 3, negative 2. We're then going to have our vertical asymptotes, which is like the opposite of what we just wrote. And then our horizontal asymptote, again, I'm just going to look at my biggest term for the top and bottom. And it's actually the same degree, right? So 3x squared over x squared. I'm going to get 3. So my horizontal asymptote is y equals 3. And then finally for the last one, we're going to do the same thing. So we're going to see if we can factor. I can't factor the top, so I'm going to rewrite it. And then the bottom, I could pull out a GCF. And so that's x and x minus 3. And then we can just do the same thing. So the domain, we look at the bottom. And we have here x cannot be 0. X cannot be 3. Because it's like you set each piece to 0. My vertical asymptote is the opposite. So x equals 0. X equals 3. And then for the horizontal asymptote, if I take the largest term for both the top and bottom, and let's say I was to simplify to make it kind of easier for us to see, this would be like a 1. You can see nothing would really end up restricting this out, right? So the top is bigger than the bottom. 5x squared, you can see, wouldn't even have an asymptote. That's kind of an easy way to check. So this one actually has no horizontal asymptote.